Paola is now a research scientist at Johns Hopkins. And after working at various places like Nuance and Tech de Montréal, I believe. And she's done a lot of work on speech processing and with a lot of focus on child speech, speech recognition and diarization. And today she's going to tell us a little bit more about the challenges of building a good spontaneous speech data set. All right.
First of all, thank you, Jonathan, and thank you for the organizers to inviting me here. So today I'm going to talk about a little bit about a story, the story behind building a data set. And we wanted to build this data set not just for the sake of building the data set, but just going beyond that, what we can do with that data set. And that is why the title is a step-by-step journey of a spontaneous speech data set toward understanding. And first of all, I want to thank all the people that over the years have helped me. Especially, well, I keep adding more and more people. Now the team that I added is the JSL OGI team. Ramen is here. Thank you very much for all the support. This is the JSL that happens like every year at Hopkins. And the AHU people, the students, that they were the ones that were hands-on building this data set. They were the ones that were taking care of the recordings, the annotations, the curation. For the people that work on collecting data set, you know how hard this can be. And of course, the rest of the people that have been always supporting this research, not only for child speech, but diarization, ASR, speech separation, and so on. And the people that, special thanks for the people that collect children's speech data sets, that they have a huge amount of data, but they cannot process it. So that, just like a disclaimer here, there's a lot of fascinating works out there. I'm just focusing on the specific ones that I'm just familiar with or that I have been involved. And so, So first of all, I have like a philosophical question. What do we really want from life? What do we really want from the speech data sets? What are we looking for? And in my case, my special case, it's just that the people from the speech language development that work with kids, they always come and they say, oh, Paola, we have this wild speech data set. We just need the diarization. We just need the number of words. We just need to tell us where the child is kind of babbling or kind of speaking, and we are not there yet. So, for example, for some of you, these scenarios could be interesting. We have the meeting scenario. We have also the speech-to-speech translation. We have the patient-doctor. And I also want to focus, or I focus a little bit on the cocktail party with the chime challenge. And the main thing that I would like to focus on is children's speech, because it is pretty wide. But let's say that we already have the transcription. That is already there, that we already have the diarization, right? But we want to know more. We want to go beyond that. So that means we want to understand. And probably Ramani will say, well, we want to go even beyond that. We don't want to get like some reasoning from those recordings, right? So we need the transcription, but also we need to know how many speakers, when they are speaking, where are the speakers located in the room, how many conversations are happening, what is the topic, what the emotion they are projecting, what is their accent, what is the language, can you give us the summary of a conversation, etc. Oh, wait. And there are a lot of things happening on this road. We know that we have ASR, diarization, language ID, speaker recognition, emotion recognition. All of these tools, we are working on all of them. And right now, the LLMs and the large audio language models are becoming super popular, right? So we have all the different techniques out there. We just need them somehow to put it together and see if they really work. But what kind of a speech are we talking about here? So these are day-long recordings from the kids. Let's take a look at one. And these ones are somehow easy ones.
No, don't touch them. That is a calendar.
I want to time.
You want to look at the calendar?
So this is an easy one. Let's try a harder one.
Yeah. Okay, everybody's...
Wait, Susan?
You are safe. You are safe. Here you go.
Auntie put the Lina on. Yeah. Okay, everybody.
Yeah. And be careful with your ears.
Baby,
Don't lick
quit
it.
licking stuff.
That is
Stop.
You know what? I think other kids touch this, and if they've got germs,
Then I say
it'll make
nasty,
you have some germs.
nasty.
He licked my fingers.
So are we able to process
right,
those? Oh,
Baby.
okay.
Yeah.
So are we right now with the technology that we have? Are we able to process this kind of audios? I can doubt it a little bit because I have been doing this or trying to do it for quite some time, and it's almost like impossible. And I always come back to the child language development people, and it's like, guess what? I'm getting like, let's say, 30-something% diarization error rate. So that is something that we have to fix, right? We not just want to focus on the speech itself, but going beyond that, how can this impact other fields? And they want to focus on the interaction, on long form. We have audios of like 8 hours long. And also, you people, how many of you talk to strangers like every day? Like real strangers? We usually talk to people who are familiar with us, right? Friends, family. So we want to focus on that scenario. And what about the data sets that we have been using so far? We have liver speech. Of course, liver speech is something that we use, like we have overused it, as probably Sanjeev might have said. It is already too easy, right? We have Colholm, Fisher, AMI, Santa Barbara Corpus, something that is similar or trying to pursue the same objectives as children's speech. We have Chime. That's why I work with the Chime people, because it is similar somehow to the wild scenario for children's speech. We have the seedlings. We have lots of data there at the home bank. The thing is that we don't have annotations for those data sets. We have MSP podcast for the emotions, and we have a new data set, the seamless interaction. This is from Meta, to people talking face-to-face, and this is kind of a line of what we want to do. And we have right now the two data sets, one from CMU and one from JHU. Ours is Casper, and the other one is the Scalable Spontaneous Speech data set. Both of them were conceived together. In the end, we both are kind of pursuing the same objective, and we are just sister data sets, and Shinji is here as well if you have some questions about the SSD data set. But these data sets depend on the applications. Some of them are very, very, very curated. The annotations are kind of perfect. And it seems that we have solved everything, right? And we have some other interesting data sets from which we can train our ARSR systems, our diarization systems, even our large audio language systems, Vox Populi, Gigaspeech, Speech, any kind of data set that is curated and it's nice out there. But what happens when this comes to the spontaneous speech I'm talking about? The performance is not as expected. There are many reasons behind this. It's because of the different domain. It's because it's noisy, not enough data. Right now, I'm doubting it because there's a lot of data out there. But in nature, it tends to be like super, super wild. And as I told you before, we don't talk to strangers that much, right? We talk to people that are familiar with us. And we behave different when we talk to strangers and professionally than when we talk to a friend or family. And there are all these paralinguistic cues that happen all the time. And just to give you an example that I already gave you before, like, all right, for the speaker diarization, for the children's speech, we can see that the diarization, the lower is better, right? And the seedlings is children's speech. The examples that I show you are from that data set. We have other data sets like BLIP that comes from the university in Singapore, NTU. And we can see that we are not there, right? Even with an Oracle VAD, the performance is around 32%. That is quite high, right? Even for both of them, one is 32%, and for Blip, it's like 41%. Of course, if we don't have the Oracle VAD, the results increase. And since for the Blip data set, we are talking about code switching, we also look at the accuracy in the code switching and the equal error rate. And you can see that the results are encouraging, but not that good. And this is already an old story. How do we envision that kids might talk? Like this. Oops.
I knew that she did all of that, but not what it was called. Dad teases Mom all the time.
Right?
I knew that she did all of that.
But how do they really talk? How many speakers are there? And
he had a tall, handsome young son named Mukane. At the time, there was no sun.
You can hear the kid in the background trying to follow exactly what the avatar is saying, right? So this is the scenario. So how many speakers do you think are there? Were there? No? 20? Where are the speakers? Any guess? Classroom? How many conversations were there happening? What is the topic? Who knows? What emotion are they projecting? Let's say that they are happy, right? What is their accent? Kids' accent, right? And what is the language? What is the language? Is it English? Is there somebody from Indonesia? No? Okay, so it's Indonesian, the first one.
He had...
Sorry. And there can be many flavors, of course. The kids cannot stay still. They are moving around all over the place, right? You cannot tell the kid, okay, you know what, I'm going to put the microphone here. You stay still, and you talk to the microphone. Right? It will move. He or she will move around. She will touch the microphone. She or he will do all things that you cannot even imagine. Okay? So we have the close talk, we have the far field, we have the reverberation, all happening at the same time. And also the kids moving around. But let's say now that the LLMs are getting very popular, we already asked these questions, how many speakers, whatever, and then we want the LLM to process all of this, right? And we ask ChatGPT. I didn't want to use Gemini, but anyway. The answer is the full verbatim audio, it contains background noises. The ChatGPT guesses that it contains 1 to 3 speakers, and the summary is one teacher, 3 students, and the topic is planning science for a project. And the scenario is lively classroom discussion at the start of a lesson. Well, that's because probably the audio is like super hard, right? Yeah. But I asked, okay, give me the transcription. What's going on here? And this is the transcription. But at the end, At the end, no, I mean, read the transcription if you want. But in the end, I was just like trying to guess, like, okay, is this English? It's not English. At least the annotation says that it's Indonesian. So at the end, ChatGPT gave us like something like, the previous transcription I gave you was not based on your actual MP3 audio. It was a simulated example created to illustrate what the real transcription might look like for a noisy classroom MP3. Well, we are getting there, right? Of course we are getting there. Then it suggested also to try Whisper. What's happening with Whisper? It's like, okay, well, it's Indonesian, you know, and there are like lots of things happening and lots of hallucinations, okay? Which is kind of scary. Well, let's try if we can try to translate it. What? Let's see if we can get like the English version of this. This is the first time I'm doing this. That is the first phrase. I'm not sure if I'm doing it right or wrong. And then it stays there forever. So, okay. So these are good news, right? That is why our data set, or what we want to pursue, is how to really get some information, understand all of these type of audios. And this is why we are creating data sets that are more focused onto that. That is the purpose of Casper, that is the purpose of SSD, that is the purpose of the Merlion data set, where we have this caregiver or mom that talks to the kid. And this one is a little bit more challenging because we have code switching. And I think that Julia will talk a little bit more about code switching later. And we decided to start from scratch. So how do people communicate, right? We recorded a spontaneous speech in like control scenario, and we wanted to simplify it. Let's start very simple. Let's try just simple telephone conversations because they are easy to deal with. And we will focus on people who know each other. Plus some interesting things. We will have like conversational spontaneity, trying to have acoustic diversity, and we have the annotations. Sometimes we have background noise, sometimes we don't have background noise. But the thing is that we want to capture realistic dialogue dynamics. And that's how Casper was born. It is, the name is quite catchy, right? Casual speech in peer engagement recordings, and we name it Casper. And it introduces we have just introduced the first part of the larger scale corpus that we want to continue. It includes diverse speakers, recording conditions. It is designed to support ASR recognition, diarization, all of these things. And it includes annotations like age, gender, native language, accent type, device type, sorry. And for the data collection, we really wanted to know how does it feel to collect data. And for the people that have done this, you know how painful it is. And we wanted to do this at a university, not at a company, so it's even more painful. And if you ever do this in a university, this is just a tip. Pizza and ice cream make a difference. Not Amazon cards, not GPU credits, pizza and ice cream. Yeah. And so we have this telephone scenario where one of our participants was in one room, the other one was in another room, and we started the collection. We have a set of different topics, and we have like this is the pipeline. So they have a registration website where they provided the metadata, age, native language, accent, U.S. state, device type, and then we schedule the conversation, we get the recordings, and we decided that it was a good idea to have like the stereo data. Right? And then we focus on the speech register, but because at the beginning of the pilot study, we saw that the conversations were like, hello, how are you? What's your name? When two strangers were talking together, which is the case for some of the very curated data sets. And we wanted it to be like more natural. So we switch everything So we made sure that the people knew each other and that they were friends or they were colleagues or they were family. And so we discovered that the way that they behave was totally different. And this data set was manually checked for that, right? Sometimes when you use Mechanical Turk or other tools, you cannot even check. We really checked, well, the students, not myself. The students really checked that that was happening. And you can observe in the data that there are laughs, they remember things that they have done together before. So that is the difference. This is just the composition of the data. We want to reach like 1K audios. Right now we have like 200 hours, 1K hours of data. We want to reach that. Right now we have just 200 hours. And the topics are daily life, technical discussions, emotional narratives. The people like to talk about food, about traveling, about, not a lot about work, yeah, but a lot about goals and priorities. And this is somehow the metadata distribution. The numbers are there. You can also take a look at the paper, but I'm just going to say that includes accent, age, device, gender, native language, and also other metadata that we ask at the end if they were happy collecting the data or not. Most of them were happy, so yeah. And the experiments at the benchmarks, we annotated. If you have ever annotated a data set, it is also very painful. It has to pass through at least 5 different annotators, and all of them have somehow to agree, right? So we have like this 1.95 hours, so it's like almost 2 hours, where we get the performance for the word error rate and also the diarization. You can see that the word error rate is quite high. And also, the diarization is even worse. But anyway, the numbers are important, but not as important than what is happening afterwards, right? So we are halfway. Okay, let's assume that we have the ASR and the diarization perfectly done, right? Well, if I have that, probably I can use an LLM, right? Sounds like a good idea, right? I'm just checking the time. Okay, yeah. So what if I give you another audio? This one comes from Casper. And this is ouch.
Look at what I've been watching. Well, I can tell you my favorite. Okay, obviously like favorite movie. Like obviously I love Pulp Fiction. Oh, I'm really excited to watch Tokyo Vice. Is it at all like Miami Vice?
It's the same producers, yes. Or one of the same producers is Miami Vice. I think it is kind of similar, but it's interesting.
So you get the idea, right? That is producing something nice, right? But we don't have the timestamps for the different speakers. It just gives you like the raw audio. Now we have to align this to our speakers, right? So that's something that Whisper cannot do right now, right? It can, yeah.
Look at what I...
Mm-hmm. But what we wanted to get is like some more information about the audio, right? And so we asked ChatGPT again, right, to give us what is the audio about. But the version that we used to process this was just the text-based ChatGPT. Of course, it cannot tell me how many speakers do we have, right? It is assuming that it contains 2 speakers. The gender cannot be determined, okay? The age, we don't know the age of the people. The accent, not inferable from the text. And it just tells us the topic, right? So we are missing several parts of information here.
Look at...
Okay, so let's try a difficult one. I want for you to pay attention to the pauses and also to the overlapping speech, because it's
the feud one is always kind of amusing because it
difficult,
does feel like
there is some kind of like like classmate
Yeah,
happening
100%.
on
Oh,
like on
100%.
TV.
And then my favorite movies, I love Pulp Fiction. Pulp Fiction's probably my all-time favorite movie.
Yeah. So that's your favorite Tarantino
Yeah,
movie.
I
for sure,
love.
right?
Yeah, I love that movie.
So let's take that one off the table for a second, and you have to now pick your second favorite Tarantino movie.
So you get the
I think I already
idea,
know
right?
what it is.
So in here, we miss a little bit of the speech from the guy because it is already overlapped. But let's ask
The feud.
ChatGPT again what is happening here. We have likely two speakers. The gender, it cannot be inferred. They are adults, probably, right? 20s and 40s. I don't know how ChatGPT inferred this, but that's what it says. The accent, it cannot be inferred. And it's a casual conversation about the
feud.
movies, right? But then, thanks to Ramani, I was involved in this MMIU project. It's a challenging and comprehensive benchmark for holistic evaluation of audio general intelligence. And it's essentially how to build a benchmark to evaluate large audio language models. And it's just quite interesting to see what is happening with this approach, right? Casper is part of the MMIU Pro. It is designed to evaluate the holistic audio intelligence across speech, environmental sounds, and music. There is also a paper out there, and Casper is also part of this effort. And we wanted to include Casper because it is our way to go towards not just understanding, but reasoning, what is behind the data set. And then somehow Ramani came with this, Ramani, his team came with these definitions about understanding the capability of a system to build representations that capture the semantic contextual, blah, blah, blah. It's just focusing on the representation and interpretation. So that means it focuses on the speech recognition, speaker and emotion recognition, event classification. But then I have to correct the title of my talk because now we want to do reasoning. Right? That's what we really want to do. It requires an intentional, complex thinking beyond basic content understanding. We require to somehow analyze in a logical way what is happening in that recording. And it's like task-oriented or inference. The main goals of our team when we were working at JSAL is to do this post-training alignment, training the question. You know that for the reasoning, we have these pairs of questions and answers that in which they have to align, and if you have like a question, it has to align with what is happening in the audio. And we tested the multimodal large language models with this question answering pairs, and we seek to improve the models. And this is the overall view of the MMIU Pro. It is quite challenging. We were just in this part, probably on the speech, sound, music mix, on the speech, probably, and the data from the kids that is not there, but we want to test it there, will be on long audio. And we have also these open-ended questions that we will take a look later. So what is the large audio language models? It integrates both the audio encoders with a large language model backbone. It enables joint representation learning and reasoning over audio and text. So you have like an encoder. It can be wave-to-vec, Huber, whatever, and then you put a language model and just make it work somehow. And it is like magic. And it supports tasks such as audio captioning, audio question answering, spoken language understanding, paralinguistics, some of the things that we need for the kids. But let's start first with Casper, right? For this, we are just focusing on a specific one. We are focusing on Audio Flamingo 3 because it seems that it's the one that gives us the best resources to tackle our problem. There are others out there that are quite as good as Flamingo, but we'd use that one. We can see the accuracies for Audio Flamingo 3 that are also in the paper. And we can see the accuracies for the speech, for the voice, for the open-ended questions, for the instruction following, and some kind of average. But what I wanted to show you is just like, well, it's not the best, but it is kind of competitive, so we can give it a try, okay? So let's go back to our audios. Do you remember our audios? This is the easy one.
Yeah, what I've been watching. Well, I can tell you my favorite. Okay, obviously, like favorite movie. Like obviously, I love Pulp Fiction. Oh, I'm really excited to watch Tokyo Vice. Is it at all like Miami Vice?
It's the same producers, yes, or one of the same producers as Miami Vice. I think it is kind of similar, but it's in.
Well, this is the output for that transcription, okay? But now my question is, who's Sarah and who's Matt? Do you see that? Who's Sarah and who's Matt? I don't know. And it is not in the recording. Do you see that? It's kind of like, okay, well, probably it's Sarah and Matt. I don't know. Yeah, no, their names are not Sarah and Matt. I'm sure of that. Well, but it just happened that it includes all of these things, right? And then
Look at.
well, let's give Flamingo 3 another opportunity, right? Okay. Now that we give it another opportunity, well, ouch.
Look at what I've been watching. Well, I can tell you my favorite. Okay, obviously, like favorite movie. Like obviously, I love Pulp Fiction. Oh, I'm really excited to watch Tokyo Vice. Is it at all like Miami Vice?
It's the same producers, yes, or one of the same producers as Miami Vice. I think it is.
Well, this transcription is a little bit better, right? At least it's not saying that it is Matt and Sarah, as are assuming things that are not there as hallucinations, right? But it gives you also some information if it's like noisy recording, if the tone is the same or not. So this is like a kind of thing that we want to see. But it didn't say anything about the rooms. Well, it says that it is like a relaxed conversation unfolds over a quiet, unobtrusive instrumental bed that fades in and out between speakers. But it didn't recognize that it's like a telephone call. You see that? So that is also interesting. Probably we are asking a lot. So how many people are there in the recording? There are 2 people in the recording, 1 female and 1 male. What are they talking about? They are talking about the TV shows.
Look at what.
And now let's see what happened. So what happens with the difficult
one is always kind of amusing because it does feel like there is some kind of like like classmate happening on
100%.
like on TV.
And then my favorite movies, I love Pulp Fiction. Pulp Fiction's probably my all-time favorite movie.
Yeah. So that's your favorite Tarantino
Yeah,
movie.
I love.
Sure, right?
Yeah, I love that movie.
So let's take that one off the table for a second, and you have to now pick your second favorite Tarantino movie. I think I already know what it is because you told me. You can say it again. Jackie Brown, right?
No.
No? No.
You're definitely
why am I
imagining it because
imagining
it's
that? Because
definitely Django Unchained.
And then we lost it completely. We are lost in the middle of the nowhere. No, forever. Okay.
The feud one is.
Let's give it a try, second try. Poor Flamingo, it can do better. And now it does, right? Now it's telling us about Pulp Fiction and all the transcription seems quite right. There are still some errors when both of them are talking at the same time. And this part, I don't know if I can show you this part. Yeah. The no, 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 it causes a lot of trouble. And also the laughing. The laughing causes a lot of trouble to these models, right? So the numbers are important, but what happens after the numbers, when we go out there and try these things, I think it's also very, very important.
If you'd
right? The difficult file, we get almost the same answers. How many people are there in the recording? There are 2 people in the recording, 1 female and 1 male. They are what they're talking about, the favorite movie. But we are still far from getting things completely right. But I believe, I hope that we are in the correct part, in the correct path. And I have many more audios, but probably for the next time.
if you'd
And this is the step-by-step that we have followed so far. We have done the audio collection. We talk about the pizza and the ice cream. We talk about the annotation, how difficult it is to get good annotations. The methods to process the audios. We have all the tools that we are familiar with, but we also have some emerging tools like the large audio language models, the LLMs themselves, and we are going not just towards the understanding, but the reasoning behind these audios. So just that we can have full knowledge of what's going on. So challenges and lessons that we learned. So there is still room for improvement for my children's speech data. Managing background noise and interruptions is not an easy task, not even for the large audio language models. And I know that you guys are more experts on other fields that can also help us. The LLMs and the large audio language models are very good, but they cannot solve all the problems. Building a good data set from scratch is not an easy thing. And ensuring those ethical data use and informed consent and privacy policies is something that that needs to be respected. And the takeaways: Casper and other data sets are pursuing benchmarks for spontaneous speech research. All of them are pursuing also to be scalable, to be diverse, and they are designed to enable robust modeling of real-world communications. This encourages us to have future exploration in spontaneous speech processing. What do you think? The large audio language model still need some improvement, right? And we need to work on real data, especially the long form. I just show you small pieces of one audio recordings. So you can imagine how difficult it can be. We need to get better at the evaluation, get the better benchmarks. That is also the purpose of MMAU, and so that we can impact other fields. Why I'm saying this? Because sometimes we just stop at saying okay, I get a good word error rate. I get a good diarization rate. Oh, now my system can really understand what is, gets a good accuracy at understanding the audios. But then when it comes to other fields like language development, like psychology, like cognitive science, we can observe that those kind of achievements are not reflected there. So we need to find ways on how to bridge. And the future work, we need to expand this to other languages. We need to incorporate more multimodal data, and we have to make this open source. Sorry, guys, for the ones that are in companies. I think that it is must to do, and we have to release the metadata for broader use, and the community benchmarks and collaborative studies should be part of our agenda. And that's all.
Thank you.
Any questions? Can you line up for a microphone if you have questions?
Yeah, sure. Hi, Paolo.
There's another one on the.
Myself, Subodh. So first of all, congratulations for the great work. Yeah, it's really appreciate for this data set. Just want to have one particular clarification on when you actually collected the data. Among the different parameters that you use, say age, gender, and there are different other ones. Did you also consider related with any speech disorder if the speaker had, or if that's something which you want to consider, right, for the future thing, how relevant actually is and how important that you feel it? Yeah, your views on that.
Yeah, that's a very, very, very interesting question. For the Casper dataset, we didn't consider impaired speech, but that is something that is like a completely separate field that we really need to address. Yeah, that is for sure. And I'm also hands-on in. I mean, I would really want to be part of that effort as well. Yeah, but it's something that we have to do. Yeah,
okay, sure.
Yeah.
Thank you so much.
Hi, my name's Silo, and a very nice presentation. And I have two questions. So the first one is, so I see the Whisper and GPT. We see Whisper and GPT struggles at kids' voice data that you've shown, but I'm very interested how does Audio Flamingo 3 does on that.
The Audio Flamingo.
On children's sound.
Yeah,
especially the Indonesian one.
Yeah. It doesn't go as good as you think because it cannot recognize the baby's crying and the bubble. Yeah.
Gotcha.
Yeah. And we wanted to focus the second part on Casper, but yeah, I have more audios and more results if you want to see them later. Yeah. Yeah.
And then the second question is, so one thing I noticed in the reasoning part, you included gender. So I'm the very annoying queer person asking question now. So is that like, that something that we think it's ethical to infer from speech only or not?
That is a tough question. Yeah, that's for sure. Even for our Casper data set, you have, I mean, for the Casper data set, you have the right to say, I don't want to give you my gender, whatever, right? If the people wanted to give, that's okay. But somehow we need to train our models based on something, right? I don't know how many categories we will need, but we need to train our models based on something, right? Yeah. But yeah, that is true. I mean, just asking these questions just to verify, right? If the gender was correct, because for this specific audios, the gender was given by the participants.
Gotcha.
Yeah, for others, I don't know if I have the things here. Let me go back to the table. Yeah,
gotcha.
Here, for example, 54 people from our data set, they said, no, I don't want to give you my gender. And that's totally okay.
Yeah, and 3%
it's part of our
binary.
Yeah, it's part of our initial policy, trying to respect everyone.
Thank you.
Mm-hmm.
One last question, maybe?
Yeah. Hi. First of all, it's a pleasure to meet you. I follow from your story from the Tech of Monterrey. I'm from Mexico as well. So,
Viva Mexico!
Yeah. Gracias por la presentación. So coming back for question, I saw you already have a data set that building with certain labels. Now, my question is like, are you thinking in adding context as a label? Because I saw you refer a lot like, I would like to understand what in the area for the kids, also when two persons are talking, even with the noise or even distance, all those factors that you're adding, sometimes when you are a large language model context, it's kind of change completely how they respond. And I see you're using that. So I'm just asking, like, if you're thinking about to add as a extra label, okay, this is the context, because in the end, I see you ask for that and they can respond you anything. But probably for future trainings, that could be helpful.
Yeah, the answer is yes. Yeah,
Okay.
we will try to do this. The thing is like the funding.
Yeah.
It's always the thing, right? Yeah, so we try to survive this with our students and volunteers. So Shinji might not, it's doing kind of the same thing, trying like, okay, now we need like 100 volunteers, and all we can give you is like a slice of pizza.
That always works.
And a big thank you. Yeah, but yeah, that's totally true.
Sorry to
Yeah.
put more effort to the students. Gracias.
No, gracias a ti, gracias.
Okay, one last question.
Yeah, thanks for the presentation. I was wondering, I noticed sort of one of the hard tasks to tackle you were mentioning was like when multiple speakers are going at once, like if maybe a baby's crying and then someone else is speaking at the same time. I was wondering if like before the data collection approach, you experimented with maybe like overlaying like single audio samples and like maybe one of like maybe an individually baby crying and then someone talking at the same time. I was curious if that method yielded any results or if you looked at that.
Yeah, the answer is that we have been trying to do that for, I don't know, probably, like 8 years or so. But the simulation is not, it doesn't reflect what we have in real life.
Yeah.
So you can have a baby like crying for 5 minutes, non-stopping, right? And mom trying to give him or her some comfort. Yeah. So even when we said, for example, for our diarization system, we are not yet saying like we can get a good ASR system. We just tackled the diarization, all right? And even in those cases, we couldn't distinguish if the mom was speaking, if the baby was crying the moment speaking, if the baby was only crying, even when we simulated these kind of scenarios. And it can be not just the crying, it can also be the babbling. Mm-hmm. There are like so many things happening there. And when we talk about these scenarios, usually they are like indoors at home. Some of them are in the lab, but the most challenging ones are indoors at home. And the baby, I didn't bring my my vest, but they're like small vests for the kids. The babies wear the microphone. So the mom could be like far away and then it comes closer. So this kind of variabilities of close talk, let's say, when it's like very close to the baby, and far field makes the problem like really, really hard, even if we want to simulate it. Yeah.
Oh,
but we have some annotations, so that's a good idea.
Yeah. Thank you. That makes sense.
All right, let's thank Paola again.